So today we're going to kind of finish some stuff up. It's going to be a much broader overview than we've done so far. And I'll end with a reflection. But one of the things I wanted to finish up with was to talk to you guys about kind of the underlying perspective that this class has been all about, the phylogenetic perspective. We use this perspective, the phylogenetic perspective, all the time when we think about plants and animals, right? When you ask yourself, if you identify a thing and you say, aha, that's an animal, your first question is likely to be along the lines of, is it a mammal or an insect? What kind of thing is it? That's the phylogenetic perspective. You don't ask yourself whether it's an herbivore or a carnivore, whether it can reduce nitrate or not. You ask yourself, what kind of a thing is it? And that's the phylogenetic perspective. Why is it so important in a microbiology class to have a whole class on the phylogenetic perspective? Because microbiology as a discipline has lacked this for most of its history. It wasn't, when I was in college, I took microbiology in 1977, and nobody knew how to phylogenetically characterize organisms. The first ribosomal RNA had not been sequenced by that time. And so there's no understanding of microbes at that time as how they're related to each other in any meaningful way. There's no evolutionary basis for microbiology. That's a very recent innovation, and it has yet to seep its way into many aspects of microbiology. Now, that being said, so what a perspective is a way of looking at something, right? Like so. And I would argue that the phylogenetic perspective is the most important way to look at microbes or biological things in general. But it's not the only way, right? Just as if I'm going to understand this eraser, I have to turn it around and look at it from a variety of perspectives, so do you have to look at organisms from a variety of perspectives. And you've learned about this kind of stuff in other classes so far, right? So what are some of the other perspectives by which you might look at organisms? Yeah?
Metabolic analysis for preferred properties we can use.
I'll call this the metabolic perspective. If you go over to the microbiologists and chemical engineering, this is how they look at microbes, right? They see them as a black box, and you put glucose in, and what comes out? How does it transform stuff inside? What's the mass balance in nitrogen? This metabolic perspective is how they look at microbes. And to a large extent, the phylogenetic perspective is meaningless to them. What other kind of perspectives are there? Oh, come on.
Like population or like a disease incidence kind of perspective, no?
I would put that here maybe a little bit. So I'll put disease on here. I'll put it in small
like
letters because I
epigenetic
think
or
that's kind of
something.
genetics, you said.
Mm-hmm. Sorry.
Oh,
I just woke up.
I need my eraser. The genetic. And another way to think about this, of course, is genomic perspective. What's another one? And so here you're looking at the organisms as computer programs, right? They're developmental programs, and they're little genetic machines. What else?
Like they're medicinal?
So I will put that under here under disease, medicinal. This is looking at them a little differently in terms of specific aspects of them. What else?
Morphological.
Okay, so I'm going to broaden morphological and call it structural. Structural. In other words, how are they built? How are they put together? What's their morphology? How do their envelopes work? How do they get things around? What's the cytoskeleton? How does the nucleoid work? And how does that divide and all that kind of stuff? Yeah?
They're environmental?
I'm going to broaden that. I'm going to call it the ecological This is the perspective in which you do look at an organism like, is it an herbivore or a carnivore? How does it fit into the nitrogen cycle? How does it fit into the carbon cycle? Anaerobe, aerobe kind of stuff. So there's an ecological perspective. And all of these are important, of course. I think you can kind of divide these into two major categories, if you will. Right here. Where this is the phenotype. The phenotype of the organism. In other words, things you can measure directly. Either chemical phenotype or structural phenotype or ecological phenotype. It's kind of the outward projection of the organism. And this then would be the genotype. It's the inside part, right? In terms of their genetic programming and information. You've studied all of these kinds of perspectives in various microbiology and biology, biochemistry classes. It's the phylogenetic perspective that I'm afraid in microbiology in general is often overlooked. And I hope that in the process of taking this class, you've come to realize how important it is to think about the organisms first and foremost in terms of who are they? Not what they can do, not who they can hurt, not what shape are they. This is the gram stain perspective, some people would say, right? And you notice we didn't do any gram stains in this class. Not where they fit into the ecology, not how their genomes are built, but the evolutionary perspective, if you will. I don't remember who said it, but someone long ago said that nothing in biology makes sense except in terms of evolution. And that certainly is the case for microbiology. All right.